All right, good afternoon. I'm going to try and keep this short because I know you guys don't like long videos and I don't want to stand up here and ramble on forever. But this video covers the worksheet we've been working on the last couple of days in where we learn how to combine like radicals. And you've got to think about what we mean by like radicals. You all have heard the term, y'all, I sound like I'm from the South, I'm not. You all have heard the term combine like terms. So like 3x plus 4x. When we combine like terms, they have to be alike. They have to be the same. 3x plus 4x, we're going to go ahead and add the coefficients, which are the number in front of the variables, and we get 7, so therefore we get 7x. Combining like radicals is no different. The radicals have to be the same. So for instance, in the first expression, the first term is 3 rad 2. The second term is 4 rad 2. I hear rad 2, I can combine. So what I'm going to do is go ahead and show my work. 3 plus 4, which is 7, and my answer is 7 rad 2. Again, combining like radicals. Same thing in number 2 here. Minus 5 rad 3 plus 11 rad 3. Minus 5 plus 11, which is 6, or you get 6 rad 3. All right? Now, what happens if you have unlike radicals when you look at number 3? Gee, I have rad 3, which is 1. There's 1 there. 6 rad 2 and 3 rad 3. Well, I heard rad 3, rad 2, rad 3, which means I can't combine the rads. So I get 1 plus 3, which is equal to 4, or I get 4 rad 3 plus 6 rad 2. That's what I get. There's my answer right there. One decimal plus another. I can't simplify it anymore. You cannot force these two together because they're not rads. Number 4, 7, and 8. I know the number is out of order. Find the perimeter of each figure. How do you find the perimeter of each figure? Add all the sides. You should be able to do that. 7 through 9, we simplify each radical. We're getting better at this, but some of us are still struggling at simplifying radicals. You simplify, and when I showed this yesterday and today, I showed it using perfect squares. You factor. So 4 times 8. A lot of students will choose that. Great. Is 4 a perfect square? Yes. So I'm going to leave it alone, and I'm going to say the square root of 4 times the square root of 4 times the square root of 2. Why? Why did I do that? Because 4 is here. The factors of 8 are 4 and 2. Now at this point, most of us understand that 4 is a perfect square. 4 is also a perfect square, and we have the square root of 2. What do we do with what we take out? We multiply. What's left, we leave as a radical. Then you can finish 8 and 9 for you. Now, when we get here, combine like terms. I am not going to cover 1 and 2 for the sake of time, but I will look at number 3 and I will look at number 5, and you can do the rest, okay? This is a short video. Can rad 48, rad 3. Can't combine those because it's rad 48 and rad 3. Or can I? Can I take the square root of 48 and can I simplify it to something rad 3? Because if I can, then I can combine those. Well, give me some factors of 48. Some of you might say 12 times 4 is 48. Yeah, it sure is. Well, gee, 4 is a perfect square. What are some factors of 12 that make a perfect square? 4 times 3 times 4. Or I'm going to go ahead and write this as the square root of 4 times the square root of 3 times the square root of 4. Same thing, right? Same thing. All of these are the same thing, just written differently. But these are written as perfect squares, and one that's not. The square root of 4 is 2, square root of 3 stays, the square root of 3, square root of 4 is 2, 2 times 2 is 4, 4 square root of 3. Done. Now that that's 4 square root of 3, I'm going to come over here and say the 4 square root of 3 minus 5 square roots of 3, and I'm going to go ahead and combine my coefficients. 4 minus 5 is equal to -1, or I get minus the square root of 3. Done. Done. Pretty easy. All right, what about this problem? And I know some of the problems on your paper differ than what I have here. That's fine. This one I believe is question number 9. All right? So, should we do this one or should we do another one? Let's do one of the harder ones here. Okay? And if we do that, then this ought to help us out. Let's try this one right here. Square root of 3, square root of 32, square root of 175. All right? And I'll leave you with this one because, actually I'll jump down. Find the perimeter. Add them all. Square root of 7 plus square root of 2 plus square root of 3 plus square root of 3. Add them all together. Add the coefficients. 7, 7, 3, 3. You get 20. Would be helpful if I could write. You get 20 square root of 2, right? Simplify over here. You got to simplify over there. So now, back to number 7, okay? Sorry for skipping and bouncing all over the place. Leave you with this. Square root of 7, that's a small number. I'm going to leave that the way it is. Square root of 32. So 2 square root of 32. Can I simplify that? Well, 2, and what are the factors of 32? 8 times 4. 4 is a perfect square. I'm going to leave it. 8 factors into 4 times 2 times 2. 4 times 2 is 8. 4 is, there's 4. All of this multiplied together would be 32. Now, I leave the radicals because I haven't simplified anything yet. Remember that 2 out front? Square root of 4 is 2. It's got to stay there. Square root of 2 is simplified. Square root of 4 is 2. Square root of 2. Multiply what I take out. 2 times 2 times 2 is 8. So 8 square roots of 2. So this becomes 8 square roots of 2. Now what about the minus 4 and the 175? Now notice I'm not using a calculator here. The 4 is going to stay out there, and I'm going to simplify this as 5 times something. Why? Because it ends in a 5. So 5 goes into 175. Well, 5 goes into 17 3 times, or close to it anyway. That's 2. 5 goes into 25 5 times. So times 35. Now I can factor this even further. 4 times 5 times 5 times 7, right? These two make a perfect square, don't they? They make 25. Well, gee, 4 times the square root of 25 times the square root of 7, oops, that's a 7, is the same thing as 4 times the square root of 175. And I know that this is a perfect square, so 4 times 5 times the square root of 7, or 20 square root of 7. So back over here, minus 20 square roots of 7. Square root of 7, square root of 2, square root of 7, I can only combine my square roots of 7. So 3 minus 2 is equivalent to 1, or I get the square root of 7 plus 8 square roots of 2. Or 8 square roots of 2 plus square root of 7. Either or, done. All right, so there's a couple example problems for you, and I'll post a video. Keep asking those questions.